Alright, so let's discuss expectation. Expectation is an idealized average. Opposed to an empirical average, expectation asks what might happen if I perform this experiment again. So, more formally, let's define expectation for scalar random variables. Let x be a scalar random variable. The expectation operator is a functional, meaning it is a function of a function that maps from random variables to the real number line. So we're going to denote the set of random variables as f. An expectation has to satisfy 5 axioms. Intuitively, we expect these axioms just by looking at the average. Firstly, we have that if x is greater or equal to 0, then the expected value of x is also greater or equal to 0. Secondly, the expected value of a constant times x is equal to the constant times the expected value of x. Thirdly, we have that the expectation of two random variables added together is just the sum of the individual expectations, where x1 and x2 are also scalar random variables. Fourth, we have that the expected value of the constant random variable 1 is the constant 1. The fifth axiom is that if we have a sequence of non-negative increasing random variables, so here we have a sequence from n equals 1 to infinity, non-negative meaning that for all points in the sample space and for every random variable here, we have that each one is greater or equal to 0, increasing meaning that as our sequence increases or as n increases, we have that the next is always greater than the previous, and this is true for all omegas. And then finally, we have that this sequence actually converges to a random variable for all points in the sample space as n approaches infinity. If these conditions are satisfied, then we want to have the property that the limit as n approaches infinity of the expected value of xn is equal to the expected value of the limit of this xn. But the limit as n goes to infinity of xn is just x. So this is going to be expected value of x. So this is a continuity condition that we want to have. Alright, that's it for today.